Hello, it's Eric here, and so welcome back to my series of videos on the latest discoveries in data science or statistical science. Yeah, and so today we're on to discovery number 5. Algos. That means computational algorithms. Yeah, and or simply just computational methods. And over the last 40, 50 years, and computer scientists and statistical scientists, they are trying to come up with very general computational algorithms. That means very general computing methods, so that these methods can be used in all kinds of different situations. Like for example, I can use one set of computing methods to do work in engineering, or to apply the same computational method in, say, organizing an experiment, or I can use the same set of a computational algorithm to do statistical inference. Yeah, so statistical inference basically means that you're trying to discover some characteristics about the population. Yeah, and so let me bring up the relevant page. So we are on to discovery number 5, and so like I said, the fifth discovery, the fifth biggest discovery in data science over the last half century is these development of generic computational algorithms. And in my opinion, this topic is probably the most complicated in all the 8 discoveries in data science that I'm going to include in this series. Yeah, so this section is quite technical, and I'll do my best to explain those intricate concepts to you. And so this topic is probably above my pay grade, and but I'll do my best. Yeah. But let me take a deep breath, and I'll start. By the way, the background noise, not noise, but background music, not music, but you hear some background sound going on because I'm sitting near a river stream. Yeah, and the water is flowing through the rocks and the stones and things like that. They're very calming, very relaxing, and that's exactly what I need, to describe these very difficult concepts to you. Yeah, and so. Okay, the first of all, so there are 3 methods, 3 generic algorithms that are like the cornerstones, of this biggest discovery of a generic computational algorithm. And the first one is what they call EM approach. Yeah, EM means expectation maximization. I'll explain what that is a little bit later. But let me go through the other 2. Yeah. So the second generic computational algorithm is called ABC, approximate Bayes computing method, ABC. And then the third generic algorithm is called AI. Yeah, it's not artificial intelligence, but AI stands for algo inference. That means algorithmic inference. And that means doing statistical inference based on some computational algorithms. And so let me take a deep breath, and then I'll explain each one in turn. Yeah. Okay, so let's deal with the first method, which is the EM approach, expectation maximization. And it's one of the earliest computational algorithms. And by the way, whenever you see the word algorithm, basically, they're trying to, estimate something in cycles. That means, you do one estimation, and then, you repeat the cycle again. You get a second estimation, and then you repeat and repeat and repeat, until get a very good, very accurate estimation of something. Yeah, and so that's the meaning of algorithm, computational algorithm. And the first method is one of the earliest developments in this kind of methods. Yeah, and then so let me give you an example of what I mean by doing an estimation, in cycles. That means that you do it again and again and again and again. Yeah. So let me give you an example. Suppose I want to estimate, the average age of the population in the U.S. So of course the natural approach is to collect a sample of residents in the U.S., and then you ask them their ages, and then you calculate the sample mean, and then use the sample mean to approximate the the average age of the population in the U.S. And but that approach, sometimes the sample mean is not a good estimator of the the average age of the population. Yeah, especially if the population, in this case the U.S. population, especially if the population has some very weird distribution. And in that case, if you want to get an accurate estimation of the average age of the U.S. population, then you need to do many iterations. Yeah, that means you do estimation in cycles. That means you do it in one cycle, you do it in the second cycle, you do it in the third cycle. By the way, the cycles are called iterations in computer science lingo. Yeah. And so the first estimate, the first cycle is, of course, you can just take the sample mean, yeah, as your estimator for the average age of the U.S. population, and then and then you calculate the chance of observing the the data points in your sample. Like for example, if you have a sample of 100 people, and then you calculate the sample mean is like 40 years old, and then but then you can based on some prior belief in the distribution of the U.S. population, you can actually calculate the chance of observing all those 100 data points in your sample. And so therefore, once you have calculated the chance of observing those data points in your sample, you can then find out what is the estimate, what is the average age of the population that can maximize this chance of observing the data point. So let me repeat. So first of all, you provide a very inaccurate estimate, yeah, like for example the sample mean, and then based on this sample mean, you calculate the chance of observing all the data points in your sample, yeah, and then the next step is you maximize this chance by choosing a value for the estimator for the U.S. average population age, And so once you have an estimate of the U.S. Average population age, then you can use that as a second cycle. The estimator for the population age, average age in the population in a second cycle. Yeah. So once you have that estimate of the average age, and you can calculate once again the chance of observing those data points in your sample. Yeah. And then once again you maximize the chance of this the chance of observing the data points in your sample by by choosing the estimated average population age. Yeah. So that means in each cycle, what you do is you come up with a first estimate, yeah, of the average age, and then you calculate the chance of observing the data points by using your estimated average age. Yeah. And then you maximize the chance of observing the data points by choosing a different estimated average age. Yeah. So that's one cycle. And then once you have a new estimated average age, you can go into the next cycle, yeah, and then you repeat, yeah. So basically, you rinse and repeat, rinse and repeat, rinse and repeat until you get an estimate that you feel comfortable, that you believe is going to be the accurate estimator of the average age in the U.S. population, yeah. And I hope I've done a good job, and I know I've muddied the waters, but I hope you get the general idea, yeah. So let me take a deep breath, and then I'll go on to the second approach, second method, which is ABC, yeah? Okay, you know what? I have a change of plans, and why don't we cut short this video and stop the video here? And the reason is that, I want to keep the length of each video short, yeah, because this video has been going on for too long, yeah? And I will leave the other two computational algorithms to the next video, yeah? So we'll call this part 1, and then the next video is going to be part 2 on the generic computational algorithms. Yeah, so the next next video is going to cover the ABC, yeah, approximate Bayesian computing, and also AI, yeah, algorithmic inference, yeah. And so let me just tell you, the modus operandi of my doing all these videos. I record all these videos on a smartphone, and I do everything in one take, and there's no post-production, yeah. And so therefore, I want to, avoid, putting too much garbage in these videos. And, I also want to stress that these videos are just for educational purposes. Yeah, they're not really to give you the technical details of computer science or statistical science and things like that. Yeah. And my modus operandi is just to give you a general idea of the concepts involved. And so I want to I really want to keep these videos intelligible, understandable, easy to digest, and so that if you're interested, you can go and do further research on your own. Yeah. All right. So I'll see you in the next video for part 2 of the generic computational algorithms. All right. I'll see you then. Bye.